Hello and welcome back to Google APIs for Rust and YouTube Uploader Development Stream. It's Byron speaking. A new day has arrived and it's a great new day compared to yesterday, which kind of ended in a sad story of me being, oh my god, I had, traits just told me what I can't do. Fortunately, I don't know. It's like good stars or something. This is something I'm going to read probably a few times because it will definitely touch some of the problems I ran into with what's all this stuff about sized and the iterator trait that I actually tried to use in Mimic and iterator X and whatnot. Iterator X, I think it doesn't even exist anymore because they changed it. And, I didn't read it yet, unfortunately, but I will. I started. And, maybe this helps at some point. But I'm focusing on what has to be done right now. And yesterday, I didn't really manage to do a lot of things. So today is refactoring. I mean, not the entire day, obviously, but I will start with refactoring, cleaning up the mess I left behind. That's always a good starting point because in the evening, night times, after like a long day of doing what you do, you don't usually write the best code in life. Okay, so first things first. Here we started to implement some filtering stuff, which is totally doing nothing. But in general, this, same as with the separation of the tests, which just was easy enough. This is why I did it right away. But I was too lazy and too afraid, I guess, to split it up into various modules. And this is something I have to do now. So it's really easy to do that, actually. First, I grab all the Lexer stuff and put it into a file that, you guessed it, is called Lexer. And it doesn't even take my input here. Lexer rs. Bada boom. Drop it. And we are totally done. Kind of. Mod Lexer, pull it in. And then we pull in all the names. Pub, use, Lexer. And what do we have? We have Lexer and token type and span. Did I forget anything? Lexer, token type, span. No, the rest is implementation. Looks good. Yeah. So now actually to the outside world, it still looks the same. So we do the same thing with the filter. We call it filters because we probably implement. Do we implement more? Let's call it null filter then. F null for filter now. Let's call it F null for null filter. Then we have one file per filter. I think that's fair enough to do, Let's keep the file small. I prefer that. I'm not sure how to, filter null to have some sort of hierarchy going on there. Yeah, for now, I think we should do it like that, I guess. F null. F sounds like function then. Filter null. I don't like underscores and module names. I mean, sure, they're totally valid, but it's like in Python where you prefer to have, it's kind of my Python way of thinking, where you prefer to have none of these around, even though that's not publicly visible anyway. It's just my internal structure here that I can change as I want, which is great. So as I can change it like I want it to change it, I just dump it here now. Filter null, I just pick it up. So here we have filter null defined and that's it. So if I want to import this here, filter null, and then we go pub use filter null, and then filter null. And now we should compile as we compiled before. Oh, cool. I probably have to look at my VPS to see if it compiled everything, but I think I did. Not relevant now. Oh no. Oh yeah, so this guy has to, I think this is also why I was a bit hesitant, but let's do this. So now we have to get the token from up there. Use super, we go up one level, now we are in lib, and we should be able to just pull token out of there. What else? Just token for now. What do you say? Better, huh? I thought so. Cool. That's the first refactoring step, worth a commit. Boom, 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 bang. Totally so. Refactor the entire library. Lexer separate. Lexer and filters. Filter null. Now has its own module. Lexer and friends have their own module. That's very nice. That is that. Okay, that's the kind of boring part of the refactoring, but it should probably show, especially myself, that splitting up into submodules is something very simple and nothing to be afraid of. And I think by now I've got the idea of mod and pub use and use super blah blah blah. I think I got it. You know, there shouldn't be a problem in future, so I can nest away basically. And I use the simple module style. There's this directory style as well that requires a mod rs in the directory to define the module, which then at the end always leads up to the library, which is the kind of the root of your library. So that looks good. Library will always be, from now on, will always be just a hub that pulls in what it has to pull in to form the library and to define basically the public interface. And for now, I think I don't want to expose any kind of submodules here to the others. I don't need that. I need that right now. Totally so. And yeah, probably have a look at this test as well. README I don't need, and that I don't need either. Good. The benchmarks, well, we might want to run this just as a refresher, because if he refactored this now, I would like to know if he, by chance get a bit faster, because possibly we do. So something that came to my mind is the way I do. I mean, it's a state machine, right? And we are always in a slow path and in a fast path. And the fast path is basically are when we detected, oh, we want to parse a null now, oh, we want to parse true false. Or a string, then we enter the fast path and we'll basically pick the characters before we reach the slow path. And this is basically our state here. We are in false parsing mode. We are in this. And right now I differentiate between these states by checking certain flags. The thing is, we are always only in one state at a time. But if you look at this, we have like lots of separate variables here that are consuming stack space, but only one of them is ever used. And this really screams for a union in C++ or an enumeration in Rust. And we really want to have, I just tell this myself, obviously, state should be encapsulated in an enumeration variant. I think that makes total sense. And this allows me to keep all the related attributes here in one union that is optimized for size. And this kind of brings down the time it takes, or the call overhead for our function here. Because the smaller the stack, the faster it is to set up the stack, I guess. I guess that there's some benefit if we use less of something, right? There should be some benefit. And if you feel that benefit, we will see. And the cool thing is that I guess it should be faster to basically match on besides that, code will be more maintainable because it will be clearer what we do. We don't even have to annotate that anymore once we have an enumeration for this. So this in string, let's see how we use it. Considering, I think this debug assertion stuff we can even take out then. I would trust it at least. And considering all that, we might be able to, just ditch a lot of complexity here. And I think that will work. So down here, we will have a state, and down here we set the state just once. And up here, we just match on the state. And we might want to change state internals, and I wonder if that actually works, but I think it should. Yeah, I think it should. We could take ref muts of the internals of the state, and then alter it. I mean, that's what we have to do. Okay, so let's see what kind of state we have. Iterator, lexer. So we have a mode. Let's keep it very, very short. This is only our internal one. A mode, which is string. And it's just a flag, right? And ignore next is still a flag that is only useful if we are in string mode. And we only handle it here as well. We don't handle it, or down there we handle it, but it's always invalid. So yeah. So this is the Boolean that I put here. This is ignore next now. This is what we know. I would like to annotate that, but I can't. String parse mode bool is ignore next. Like that. And I don't have to really put doc strings in here because nobody will see them ever. So let's not put doc strings. I mean, let's not make the wrong impression here. Identifies the state of the lexer. I know it's not used. I will use you. I will use you soon enough. So then we have the various null, true, false, and they all have a buffer of varying sizes and a cursor into the buffer. Okay, that's cool actually. So let's go with null parse mode buff and buff index. So here we go with null, and then we have a buffer of a predefined size, which is 4, and it's a char buffer. That, I hope that works, but I think it will. Why shouldn't it? And the next type here is the usize. Let's call it I. Oh no, we can't call it I, we only can make it a usize. Like so. Okay. Then true parse mode. Let's call it like this. Like this. Now we go with true. Still the same amount of characters, still the same layout. Then false parse mode. And that's now 5. And that is pretty much it so far, right? Null, true, false. There we go. Cool. Bang. Should still compile, but we have a warning for an unused enumeration. Good, but we will use it very soon. So first, what's this first? Oh, look at that. That's actually for, oh no, wait, that's something else that we will probably have to review at some point later, but not now. For now, we are good. Ignore next is something we don't need. In string, we don't need. I just put the stuff that will be in our state right here. And this is still something separate that I guess I will touch at some point. So let mut state be a mode. Oh yeah, and we have the standard mode. Slow path. Standard mode. We start in. Actually, let's do it by exclusion, because that way we don't have to be exhaustive. This also means that this needs to be an optional. Yeah, so how do we do it? Oh no, wait, this will but then be part of the match. Okay, let's put it all inside of the match. So we need a slow path. Slow path, let's call it like this. Which is everything else where we try to get our signaling characters that put us into a fast path. Slow path, and that's it. And we start off with a slow path. slow path. Here we go. That's the state. Oh, yeah, and how is this? Oh yeah, true. At some point when we enter the state, we have to initialize the buffer as well. So this is what we do here all the time, and this costs time, you know, this is not for free. And we do it no matter what. So we are wasting cycles deluxe. And we are not doing that anymore either. So that's pretty cool, I think. That's super awesome. So I think we will be faster at the end because we do a lot of unnecessary work here. I don't know if that gets optimized away, but if not, then we will be faster. Okay, so now we will match on this entire thing. Match on our state. Boom. I will put in what I have done. So let's do the slow path first. Slow path will be another match, and I just don't put the comma here because that should always be the last. So I just take everything out of here and single character match. Is this truly the end of this? Yes. Okay, so here, that's the one that goes into that branch. Boom. And you want to put it 1, 2 tabs to the right, and that's our slow path. This is and slow path. And case slow path. And this is and match state. Good. Now let's do the string case. Or actually, let's do the string case, but only here. So if you want to do the string stuff, then we say, oh, we match in our state, and now we want to change it in the same process. Guess what? That doesn't work. Yeah. So that's the shitty thing. Now you would have to clone it all the time. Oh, and clone. Oh. I'm not sure about this. I could have a next state. Yeah, I think this is my current state. It's all about not operating on your actual state then. But I also don't want to copy it all the time. So if you have a state change, we have to some sort of schedule a state change now. And I think the way to do this is to have an optional that we have to check then. So that's a bit more on the CPU and also an optional state. So we are blowing up our stack size a little bit again because we kind of have to keep 2 states just because we can't override us while we are going for it, which is sad. Because that's kind of an efficiency penalty just to get the borrow checker to like us. In fact, the borrow checker could say, well, I don't care. It's the last thing you do. So technically, but it can't detect that. That's the problem. So it's really like this workaround shouldn't be necessary. And this is costing us performance then. And, not nice. Next state. Let my next state be an optional mode. And this is our state change here. So we will work with that for now just to be able to work. And maybe we still have a benefit in terms of performance. If we don't get slower, I'm already happy because this code will be better than before in any case. So here we schedule our state change. Next state is some mode string. And we start with false here, because we are not excluding anything. That's the next one. That goes away. And we are fine. What's your problem, man? User moved value state. Where? Well, yeah, well. It shouldn't be moved in there, man. Can I take you as a reference? There we go. As a mud reference. Because I am going to change internals. Unused variable, slow path. Excuse me? Slow path. Oh, now I see. So the thing is, like this, huh? No. Hey, so I don't want to consume this thing. If I have to clone it anyway, you know, I don't want to clone it. That's the point. I just want to match on it by reference. So what's the deal? This is not supposed to move. My dear. No movie, no movement. And now it becomes a borrow, and I'm kind of working on a borrow here. This is kind of what I want, but I want to, you know, what's now? It hates me for it. I am amazed. Why is it consuming the thing? Because this is why. This variant here. Yeah. No, but still, what's the deal with my state here? I should just be able to do what I do. This is unused. Okay, fine. Okay, I see. If I take it as a ref, because I'm dumb, man. Okay, what's the problem now? So here, I was actually never referring to the slow path. So yeah, okay, fine. You can have that. That's good. I might at some point try. I can't assign my state while I'm matching on it. I wanted to say I might try, but it's probably not worth the time and effort. So the thing is, let's go down here right away. Match state, and here we are for each character, not to forget. And we do a match on our next state, and we can consume it. No, we shouldn't consume it in the process. Or should we? Actually, we want to take stuff out. We probably can do this. We have to check ownership details in that moment. I'm not super sure about that. I want to actually take out what's in there if there is something in there. And I don't want my program to panic if that is not the case. Takes the value out of the option, leaving a none in its place. Okay, so we can basically take it out, match on it, and then assign it if possible. So this is what we do. Boom. So this will now basically be empty. It's kind of quite some overhead here. So we lose some here. But I'm happy. You know, this doesn't need to be honestly, maintainability over the highest performance ever done in Elixir. Because if you have seen Elixir that has the highest performance ever done, you probably won't understand the code even if you wrote it just a day later. So we want to have easily to understand code and, you know, use the language to our advantage, because after all, we are still like probably twice as fast as Go would be in the same moment, while having more maintainable, more readable code. That's really what this is. And maybe not twice as fast, but maybe, who knows? Okay, so we take out the next state. and match on this. So if it's none, we don't do anything. Like this, I guess. People also do unit here, or some state, we take it out. We consume, I mean, it's a new option we get, right? We just consume it and assign it to our state, which now is free for assignment, like this. Boom. And there we go. Now we have circumvented all the ownership issues that we would have here. So now we just do it like we do it. And in-string is now implemented, at least on the how do we get into the in-string mode part. Next, let's implement the actual path here. So we do mode in mode string, and we have ignore next, which is a mutable reference because we want to just change the interior of the state, right? We want to change what's in there. We don't want to take it out or do funny stuff with it. Cool. So now we can basically, if I'm not totally mistaken, do exactly that. It should be a one-on-one copy here. Boom. And I wonder why I'm too far. So indentation isn't correct here. Now it is. Does that look good? Yeah, it does look good to me. Continued token type. Fine, that's also part, in a way, that's also part of our state where you just keep it separate. That's totally fine. The more separate stuff we have, the easier it is to assign things and override things, right? So the state magic we have to do here, it would be so great if you could assign the state and the circumstances. But on the other hand, you know, this is very, very clear what's going on. This makes it very clear. I like that in a way. So let's do the null modes. In order to get into the null state, we have to now initialize our state accordingly. So null mode, next state is sum mode null. Oops. And now we go with our initialized buffer of 4 characters, which do not matter. We just make them something that is definitely not null. And our index, which starts out at 1. And considering we know what we want, we can initialize with C here. So that's C. And the next one that we want to write is 1. So this is now just this one statement here. And we are done. Voila. I like it. And now we do the same thing. We take this null fast pass up here into its own case, mode null, where we have the B. I just call it from now on B and I. And B is a ref map because we want to change it, and this is also a ref map because we want to change it without taking it out at all. Boom. Now we have to do a little bit of renaming here, but the cool thing is these will look very similar then. So that's B, I is C. If I is 3, so we are at the end of our parsing, then we just check if that's still the case. Boom. Then we can adjust the token type, break out of this, or we increment I, which is more like this now, just because it is a reference, not to forget. Oh, and considering this, we have a reference here. We always have to deref stuff in the moment we want to use it literally. So that is what happens here. Yeah, that's the code, I think. And I will not stop before I have everything up here, because then we can let the compiler tell us. I won't even save because this will make a lot light up red possibly, and I'm not yet done. Good. Now, same thing here. True fast path. Let's go down here. Next state is true. Then we have first is this character. Then we have TRUE 5 as 1. Boom, boom. And we are done with the state setter. And now, once again, we take all this code and adjust it. Oh, wait, sorry. I can't count. TRUE is still 4. So let's do it like that. The compiler would have told us that this is nonsense, but my brain told me before. Have that, compiler. You have to try harder to get me. True. So again, we have red mod B, ref mod I. I also want to change it in place and put it down here. I'm deliberately not copying what I have above because it's pretty much the same thing what we do here because, you know, let's see if I can get it together. But it's the same thing. It's never it's always required to focus. It's easy to make copy-paste mistakes, totally so. So that's Boolean true, that's still right. We go with I, and we are done. And that's that. Look how simple this looks now. Less stuff going on, it seems. And that's good, less visual noise. And if you look at this, this could even be kind of a function, huh? Now, a little closure that we can dump here. Ignore next. Ignore next. String ref mat. Ah, okay, true. Here we go. Like this. I forgot it's a pointer for a moment. So, and this index access, that's auto dereffing at work. So we don't have to deref B all the time, which I find very, you know, it's just for comfort basically, which makes total sense, by the way. Good. So now the false fast path, kind of the same thing. I will be lazy enough to copy this because it's kind of it really is the same thing. Just that we have false here and 1x in addition to that. Boom, boom, we're done. And that is that. Awesome. So we now take this up there, clean up our variables and state. Let's kick it now that we are here. And add the new path. Mode false. Ref mod B. Ref mod I. It's cool that, you know, the same thing is now has the same name, which previously we couldn't do because they all had to occupy or have to get their own binding on the stack so that we can refer to them separately. But now it's kind of all reused, which is totally awesome. One to the right, looks good, indentation-wise at least. And now B5 is I, is C. Then if we are at the end of our match, we try to match everything. Let's adjust this as well. Let's not lie in our comments, which is worse than having no comments, as we all know. And then here we take it up a notch. And we are done. And that's the new Lexer code state change, which is also as obvious as it gets, right? And yeah, we do some extra work here, but on the other hand, I think this can be optimized quite nicely. Yeah, I didn't want to see this bunch of text on the left all the time. This noise. So now we can basically figure out, it should basically just tell us that this is all unused, but I know that it is unused, so let's kick it. And the cool thing is we don't do all this unnecessary initialization anymore. This really matters. In string is not used anymore. No. Ignore next is now part of the state. And this is the new internal. And I don't see any obvious red here. Let's build it. Oh, that's filter null values. Where's the other stuff, by the way? Why did it not run my... It should run all the tests. It just runs a single test right now, which I find a bit odd. Why doesn't it pick up the Lexer tests? Excuse me? I mean, the good thing is it compiled it, apparently. Is this some sort of feature? Here, Lexer. Does it now remember what it did last? Ah, it aborts. Ah, it aborts on the first failure. Can you say to keep going? No. Interesting. The board's on... Yeah, the board's on the first failed test. Well, fine. Saves time, huh? I didn't know that. Look at that. It still works. Awesome. Let's bench it. Curious. And we are faster now. Yay! Our refactoring doesn't only make more maintainable code, it also makes it faster. And that's awesome. And we have some overhead thanks to the unnecessary kind of state juggling that we do. This makes for very easy to read code. You know, and yeah, anyway, I'm very happy with that. And this is an idea I had yesterday. And it's kind of interesting, you know, how code evolves and how it gets better and better. And we're getting somewhere here. That's not too bad, because we will lose a lot of speed when we, you know, this doesn't matter really, because at the end is how fast can we filter stuff and basically deserialize it or we lex it into tokens, then match on the tokens, and then reserialize it into the string or into bytes basically. So that's gonna happen today. Cool. Let's finish the state of our refactoring. Refactor as the Lexer. Use enum for state. Instead of using many different variables for handling the state, we use an enumeration. That way, we don't unnecessarily initialize memory that will never be used, and lower our requirements for stack space. Unfortunately, oops. We can't assign our own state while matching on it. Which incurs a small penalty both at runtime and also in terms both at penalty in terms of cycles and stack usage. So we could use kind of just one state otherwise, and we wouldn't have to do all this state checking, this next state checking after each character. Yeah, but hey, that's how it is. Can't change it. So we could be a bit faster there and a bit better. But yeah, just for the fun of it, I might try to set my own state while I'm sitting on it, basically. And I guess this still doesn't work. So can I set my state to mode string, to mode slow path? Can I just set it? Wait, Are you kidding me? It doesn't mind? Okay, I will set it to something that is valid. No, wait, it will be overwritten later anyway. But does this work, man? This works. This is new. This is new. Awesome. Awesome. Oh my god. Because I am in something that doesn't have a variable. Awesome. Let's kick this. We are fine. We are good. I will amend to this commit. No next state, man. Cool. So we can now compare the difference between what we had and what we will have. 294. Awesome. So all this just goes away. Boo, boo, boo. Nice. I didn't know that. But I'm excited. I can just say next state will be state. Thank you. Oh, now you don't like it. Oh yeah, because it's a sum. There is no sum. And the next state is gone already? It is. Yeah, let's quickly adjust this. I like using the linter for that kind of work. Really works well for small projects. And this really tells you, damn it, whatever you do, put it into a small crate. You don't care. I don't like the project overhead that you have, because if you want to do a good README and stuff, you have some overhead, but there's something you could possibly alleviate at some point. So let's run the tests. Work. Let's run the benchmarks. 294 versus 323. Awesome. Struct field is never used. Okay, that's so amazing. We are even faster now. 323. That's because we got rid of this even unnecessary overhead. See, don't prematurely don't preempt the borrow checker, you could say, huh? I was preempting it for good reason, but this only kicks in if you have borrows to actual, if you have a variant here that has something in it. Only then you can't overwrite the state. That's totally awesome. But maybe that at some point didn't work. I mean, I have made my experiences, but by now it does work. It's just getting better and better all the time. Awesome. So let's put it in. Cool. So we are just 100 megabytes slower per second than we were initially when we had just simple string parsing implemented without anything else. There's nothing with unfortunately here. Just perfect. Voila. And that shall be this session. Thanks for watching and have a good day.